Well, I've been given the green light. Good morning, everybody that's in the room, and good morning, everybody that's online, or good afternoon or good evening, depending on where you are on the planet. So, my name's Mark Wilson. I work for BMC Software, and I'm a mainframe techie. Have been for a long time. I lead a team, a global team that runs around the globe doing security stuff and mainframe stuff, but basically look after a team of mainframe systems programmers. So today we're going to talk about integrity. Now I'm going to get some of this wrong, okay? Only because I will slip back to my native tongue and call it ZOS, right, rather than ZOS. So I do apologise, but they both mean the same thing to me, okay? So, a little bit of background. I started in mainframes in 1980 as a trainee computer operator. I left school 3 days later, started work as a trainee operator, and that is all I have done all of my career. So I'm now into my 42nd year of being a mainframer. You'd think I would have learned something by now, but I'm still learning stuff about this each and every single day. I started off in that black and white picture, loading 3420 tapes manually. So literally running around the machine room, stacking them up the arm, loading them on. There was no automation. Yeah. We used to wear roller skates because that's how we speeded up the process to get the tapes loaded quickly so we could get the jobs run quickly so we could get home early, because it was a get the work done, go home. Very rarely did we go home. We might have gone via the pub as we did this, but yeah, that's the general idea. And obviously today, yeah, more modern mainframe, everything automated, everything secure and locked down. Nobody can come and do anything to our mainframes from a nefarious intent. Battlecruiser, first picture, was never intending to go into IT. I was going in the British Navy. I went to do something for 6 months in between the day I left school and the day I was supposed to go in the Navy. I went to do this thing for 6 months. 3.5 years later, I changed my job. And 42 years later, I'm still doing the same job. So there we go, by way of an introduction. So we as normal human beings trust people. We trust people, we trust partners, we trust our customers, we trust everybody for a moment, okay? Our natural reaction or our normal behaviour pre-COVID was to walk into a room, introduce to somebody. What was the first thing we did? Hand out, shake the hand. Nice to meet you. Nice to meet you, Walter. Nice to meet you, Greg. First time, everybody. And until somebody does anything bad to you, our normal stance is, well, I trust you. You're a nice person. You're a good person. You would never do anything bad to me. That's the basis of some of this presentation. Not all of it, some of it, but trust, okay? Because we trust people who work on our systems. We trust people who send us code, the software vendors, whether that's IBM, BMC, Broadcom. We trust them, okay? But should we? Yeah? Should we trust the systems programmer that's been sat at that desk for 40 years doing the same job? It's Bill's system. He looks after it. Bill wrote the code. We trust Bill. Yeah? But should we? So we're going to talk about that. But who thinks their mainframe is really, really well secured? We've locked the ESM down. It doesn't matter. RACF, ACF2, top secret. We've got everything in place. We've got all those fancy profiles in the serve-auth class. We've got role-based access control. Everything works. All those processes are done. Data classification. We're doing all that real-time alerting and logging and monitoring. Happy? Do you feel secure? You never know. Should we be? Should we be absolutely certain that everything on our mainframe is absolutely as it should be? And the problem is we can't be, because as security specialists, if that's what you do in your organization, we only control part of the security challenge, not all of it. Because a large part, in fact, pretty much everything that we do relies on that system and that system code, and all the bits that run on it follow the IBM integrity rules. So It's the fundamental building block of everything we do with security. If you had an integrity issue, what could happen on your system? And this is what this presentation is about. Yeah? Let's look at what integrity means. Let's look at what that means from a statement from IBM and most of the other vendors, what it means for us as practitioners, what we need to check, what we need to look at. Because if you don't have integrity, all of that work you've done in RACF, ACF2, top secret, all those wonderful processes, that real-time alerting, that file integrity monitoring solution you've got in place, we can bypass all of that. So we have to trust the code that comes from IBM, ZOS, doesn't matter whether it's Kix, DB2, IMS, MQ, keep going along the list, but also all of that ISV software. We have to trust that they are doing as we need them to be doing, that they're following the rules and the guidance from IBM. But more importantly, what about that little bit of code that Bill wrote 20 years ago on a Friday night because you had a batch problem or a production issue, and it was, don't worry, I'll write a piece of code for that. Have we ever checked that code and looked at it and said, is this following all of the coding rules? And the coding rules come from IBM's ZOS integrity statement, first delivered to us in 1973. So back then it was obviously ZOS, it was MVS, then OS 390, then ZOS. But the integrity statement has been constantly updated to keep in line with that. And basically, it's a set of rules that IBM commit to honouring. And in simple terms, it is you are only allowed to do what the operating system wants you to do within a set of rules. Okay? But, and there is a but, and that is unless allowed by the installation. Okay? So IBM will follow these rules. You, as the systems programmer or the writer of the code or the security expert, can change this. You can say, I don't care, I'm going to bypass all those controls. Okay? The primary tool that we have for controlling this is what we call APF authorization, authorized programming facility. Now, I always have a hard time with the next statement, because when the mainframe task is running normally, it is deemed to be running in problem state. So problem state is good. So think about it as a container. You're in the container. You can only play with your stuff and read some of the system stuff. I can't jump over to the next container and go messing with the stuff that's in the other container. Yeah? So problem state is good. That's where most normal user tasks run, problem state. That allows that problem state task, program, batch job, whichever way you want to do it, to issue certain hardware instructions, but not all of them, okay? What this means is the set of privilege instructions, as I would like to say, the good stuff, is only allowed if you can move from problem state to what we call supervisor state. So supervisor state is where you want to get to. So if you can move from problem, which is good, to supervisor, which is better or bad, depending on your view of the world, that's where you want to get to, because now you can get to all those other instructions that do the good stuff. And the good stuff is I can jump from this container to this container and mess with this container's data. This address space, I can get in there, I can look at things, I can change things. I can change pieces of code or pieces of storage that I shouldn't be able to play with as a normal user. So I'll pick RACF as an example. When you log on to TSO, you get your TSO address space, And there's a little control block that's created called the ACEE, Accessor Controller Environment Element. It contains in there all the bits of information that RACF uses to say whether you can issue certain commands. Are you system special, group special? Do you have the operations attribute? As a problem state user, I can read that. As a supervisor state user, I can change it. So I can log on to TSO, and if I have a piece of authorized code, I can go and make myself RACF system special, or operations, or auditor, or pretty much whatever you want to do, because you're in complete control. So, yeah, the way that we protect this, and we're going to do this one to death as we go through this, is APF authorization. If you want the ability to flip from problem state to supervisor state, you have to be APF authorized. Now, there are a number of different ways. You can see some boxes down the far side of the chart. There are different ways you can become APF authorized, what the system would consider you to be APF authorized. And for a long time, we were fixated on just checking and protecting and testing the APF libraries. But there are so many other things you can do. Things like LPA list, things like linked list if you haven't coded things properly. So we as security professionals are fixated on making certain that only the people we want to be able to flip from problem state to supervisor state are really, really tightly controlled. Okay? So there's different ways, there's different things, there are different settings, controls that the operating system allows us to issue these authorized codes. First one is, I am actually supervisor state. So I've already got the keys to the kingdom. Or I'm operating when the PSW, the program status word, and we could have a good hour just talking about that, is operating in either key 0 through key 7, okay? Or it has a protection key. Or the actual program has been loaded from an APF authorized library. But there are two keys to being APF authorized. One, I'm loaded from a library, an actual PDSE, where we've told the operating system anything in this library could be APF authorized, because you also need the second key, and that is the module has been assembled and linked with a code called AC1. And it's just something in the binder, in the link editor, that puts a little flag in there that says this can be APF authorized. For it to be APF authorized, it's got to be loaded from an APF authorized library. However, as security folks and systems programmers, we can only control what's on the APF list. There is no security check when you do that link edit to say, I'm going to make the module AC1. Anybody can create that. So I can have my little play system at home, create a module, AC1, copy it down to my laptop, walk into a site on a USB stick, whichever way you want. I could then load that code up to the mainframe. I don't have to assemble and link edit it. I've just got to place it in an APF authorized library. Now, I should not be able to do that, but if I can, I've now got some AC1 code in an APF authorized library. Game over, okay? That's it. Put another 50 pence in the meter and just do as much damage as you want to do. Because once you are APF authorized, and I'm going to steal my thunder for one of my slides later, you are only limited by your imagination and coding skills. It's as simple as that. Yeah? If you allow somebody update authority or the ability to get access to update an APF authorized library, and they know what they're doing, they can do whatever they want to the system. There are some other bits we need to think about from an APF authorized library perspective. I'm not going to cover every single one of these, but now this is where oh, there we go. Look, so this first one here, what this is talking about here is when we IPL the system, ZOS reads a static list of APF authorized libraries from a palmlib member or an IPL palm member, prog XX, where XX can be 00 through ZZ and 01 through 09, okay? But it's a static list. But it is read so early in the IPL process that it cannot validate that the data set actually exists. So if you rock up to a site and you look at all the APF authorized libraries and you say, that one actually doesn't exist, if you have the ability from a security perspective to create that library, it is automatically APF authorized because the list of the libraries is held in storage. It doesn't matter where the data set sits on the disk. You don't say it's got to be on disk XYZ. Yeah? Most sites just go SMS these days because it could be on anywhere. So I've got this library that's sitting on a volume that I've created that's APF authorized. Because I've created it, I can populate it, I can put some data in it. And there are a few other bits that we need to look at here. The second one is automatically APF authorizing all of your linked list data sets. There's a palmlib setting in IEASys that says link auth equals APF tab, okay? What we're saying here is if the data set is in the linked list, automatically APF authorize it. No, don't do it, okay? Because what you're going to end up with is lots and lots of data sets that are in that APF table list now. And if you can just find your way to update one of them, you can pop your APF authorized code in there, you've got problems. Other few bits and pieces, LPA list, okay? They are automatically APF authorized. So if you have any code sitting in any of the link pack areas, modified, fixed, and they're in that LPA list, they are automatically APF authorized. That's just the way, nearly said ZOS then. That's the way ZOS works, okay? You've got to take care of it. So don't be fixated on just looking at what's in the APF list. If you've put everything in the link list, you've got to check that. You've also got to check all of your APL and LPA libraries, okay? The whole thing about this slide, yeah, is just get me into supervisor state, okay? All the different checks, yeah? There's PSW keys, PSW masks, we can go through all of this. But this is our control from that shift from problem state to supervisor state. Okay? We've got to start thinking about how this works, okay? The real control is the hardware. That's the first line of this. The hardware does this for us, okay? So when you load a program, it has a setting, okay, that we look at, or the operating system looks at, to say, is this program in problem state or is it in supervisor state? And that information is actually held in the PSW, okay? And it's the problem state bit. And we look at that and say, if the problem state bit is on, so I am in problem state, then I cannot issue any of the privileged instructions. Now, as a bad actor, I want to come and switch that. I want to say problem state off. Because if problem state is off, I can now go into supervisor state. Well, I'm technically there. So I'll put these slides up there. I've got to admit, I only finished writing them about 4:30 this morning, but that's just a different story. But I'll put these up on the share website. I've actually got a couple of hidden slides in here with some pictures of the PSW and that for you to look at if you want to really understand it. But it's the PSW and the hardware which is the real control. And it's that ability to turn that bit on and off is what we're really interested in. And that's where we want to get to. So we know how it works. We know where the control is. Where's the problem? Well, the problem is we didn't really think about secure coding when some of this stuff was written. You know, the exit that Bill wrote 20 years ago, the SVC, yeah? The little bit of code that comes in and it's, oh, it's Mark, it's Monday morning, it's 10 o'clock, we'll flip him straight into supervisor state because he's got that job to do. We didn't put a SAF call in there to check ACF2 top secret RACF to see if I was allowed to do that. Yeah? I actually did a test for a client many years ago and we just dumped the code on the screen, just browsed it there, and we disassembled it and you could see it coming through and it did a password check. The first thing it did, he said, yeah, have you supplied the correct password? And it just did a simple compare for the password. The password's in clear text in the object. We could read it. And the password was password. We've actually seen another one where the password was yes. And it's not really the way we need to protect it. So if you do have code like that, okay, you've got to put a proper SAF check in it. So it calls RAC FACF2 top secret and says, you know, is Andrea allowed to use this facility? Is she allowed to flip from from problem state to supervisor state? You put a security check in. You might create a profile in the facility or ex-facility class and say, you know, yeah, supervisor state dot yes. And if you've got access to that, we'll allow the code to flip you backwards and forwards. We never did that back in the 70s, 80s. I'd probably say the 90s, because we didn't think anybody was going to ever look at our mainframes. Yeah. They were all going to be. I remember when I started my job in 1980, my first manager said to me, Mark, learn something different. Yeah? These mainframes aren't going to be around forever. Okay? We've got clients who are 10 years, 15 years into a 3-year project to get off the mainframe. And that's caused us quite a few problems because we're getting off, we're not going to invest in security. So that bit of code that Bill wrote just gets rolled forward every ZOS release. My favourite is you go in, you find this stuff, and you ask the client, where's the source code? Ooh, we haven't looked at that source code for 20 years. But you're running ZOS 2.4? How did you get it from that 2.3 system? Oh, we just copied the module. So you've copied a module into an APF authorized library that's link edited AC1 and you do not know what it does. Yeah, but we need it for the batch process. There could be anything in this code. And we just quite happily copied it and copied it and copied it. Yeah, they tend not to be big pieces of code, little exits or little SVCs. They're not, 2,000 line programs. So you can actually disassemble them and reverse engineer them and rebuild the code. But really, we should have the code. Yeah. So when we talk about secure coding, we talk about, the things we should be doing when we write code that does need to be authorized. There are times when the code you write needs to flip from problem state to supervisor state. And some of the simple things are validating the inputs, yeah, not allowing things to be modified. I've received a parameter, yeah. Don't just go and process it, check it, validate it, yeah. And there's a whole bunch of stuff out there on the internet, yeah. I'm going to talk about some places to go and look that teach you how to do this. It's not easy, but it's not difficult, okay? It's just a coding technique, yeah? Check, validate, trust nobody. The handshake, forget about the handshake. I trust nobody. And that's what you've got to think about when you write the code, because if you get somebody to come in and pen test your system, they are going to go straight for your APF authorized libraries, your link list, your LPA list, and any code that sits in those libraries that's link edited AC1. That's the first place they're going to go. I guarantee it. They will go there. So if you've got that bit of Bill's code that we haven't looked at for 20 years, those pen testers, those hackers are going to come in and test it straight away. So secure coding is how we protect ourselves. Because remember, Murphy's Law does get us. If it can go wrong, it probably will go wrong. I have walked into a client site and sat down and had a conversation with them. And they said, yeah, we've got this bit of code. Bill's had it for years, but it's okay. We've checked it. First test, bang, took the development helper down. Just by attacking this piece of code. Now, we warned the client of the challenge, but denial of service attack, it was really, really simple because you could see in the code that it would have some problems. So secure coding is really important. More importantly, to me now in 2022, people are looking at these systems. People are actually interested in the mainframe. They get into the network, they shift left, they shift right, they're all around the network, and all of a sudden they pop across an IP address. Don't know what this is. They'll put nmap in and they say, it's got this 3270 server running on it. What's that? Bit of Google. Oh, it's a mainframe. Is there any information on there about how to go and footprint or attack a mainframe? Yes, lots of it. So there's Lots of interest in this. We have for many, many years hidden behind the fact that nobody really understood what we did. Okay, there's help out there. Now, I'm quite disappointed that Brian's not here. Okay, because Brian is one of the most infectious IBMers I have ever come across. Okay, and I put the earplugs in the bottom left-hand corner to just poke a little bit of fun at him. Okay, because I'm loud. I know I am loud, especially once I've had a couple of beers. Brian's louder than I am. But Brian runs, yeah, the ZOS security and pervasive encryption team at IBM. They do a lot of really, really great work. You can follow him on Twitter. They put stuff out there about how to do all of this stuff, okay? If you haven't been here, yeah, get a little bit of education. Has anybody been to this site, the Enterprise Knights of IBM? There are some fabulous videos out there and blogs and articles and downloads that talk about this type of stuff, how to go about secure coding, the things to look for, the things to do. Okay, I've put the link in here, but somehow Mr. Childs managed to get his team to agree to be videoed, and then he animated the videos. So they've all got cartoon faces and cartoon heads in this. So they've tried to make it quite fun and interesting. There's a lot of stuff out here. There's probably 25, 30 different videos and countless articles and blogs. But if you want to start thinking about this and understanding how to do that secure coding, then that's the place to go. The Enterprise Night stuff, they actually did a session in here yesterday, broadcast live. It was good fun. It was a little panel. But there's a really fabulous team at IBM who do this. Yeah, there are folks at Broadcom who will talk to you about this. There are folks at BMC that will talk to you about this. Yeah, there is help out there, because really what you need to be doing on a really regular basis is actually scanning your code, because it comes back to trust. We trust that the people who write all that software, whether it's Bill, whether it's IBM, whether it's the vendors, we trust that they've done it right. We are human. We will make mistakes. And if you make a mistake, you could introduce an integrity vulnerability into your environment. Now, has anybody in the room not heard of Log4j? Okay, that caused quite a stir when that just popped up in December, and holiday was cancelled for any security professional over the Christmas break because it was, have we got this vulnerability in our code? Okay, now that was specific to Java and the open source, but vulnerabilities have been found in ZOS, in Kix, in all kinds of software. Yeah, not just IBM's, not just Broadcom's, not just BMC's. All vendors have had problems, because people make mistakes when they code. So you need to scan your code. IBM have an authorized code scanner, okay? KRI Security have an authorized code scanner. They are commercial options. You have to go and buy them, okay? If you can't afford one of these, you got to find a grizzly old assembler programmer, yeah, who's probably somewhere in your organization. I've been told off for saying this once or twice before. You might have to go down the cemetery and look at the headstone, and it says, yeah, mainframe assembler programmer. Yeah, let's get them up and get them back to the office and But you need people who understand this to go and check it. So if you can't get the commercial ones, yeah, speak to the people in the organization who do it's 99% going to be assembler. Yeah, we can have a little bit of Rex out there these days. You can do system Rex. But you've really, really got to dig into this stuff and make sure that you don't have any vulnerabilities. I can say that most of the large vendors these days scan their code or test their code before it goes out. Okay, so it's largely good these days, but you do find problems every now and then. So quite often in a conversation, there's the debate about, do I scan or don't I scan? I am an absolute believer in, we should have in our mainframe environments some kind of scanning process of our authorized code as we change our systems. Now, that might be every time you do an RSU maintenance implementation, anytime you upgrade ZOS, so you're going from 2.3 to 2.5, build the system as it should have it. It should be baked into your change management process that you scan this system before it goes into production. But you've also got to scan it when it gets to production, because we have development and we have QA and we have pre-prod, but it's never quite the same as production. Now, don't go and scan your production system at 9 o'clock on a Monday morning, when you are being hit with 1,000,001 banking transactions. DR is our friend. Replicate the system, fire up the DR system, and scan a copy of the production, LPAR or Sysplex. Scan them all, okay? And do this on a regular basis. I wouldn't advocate scanning the system if you've put one PTF on or two PTFs on, but a little bit of common sense. I've put RSU maint. RSU maint, if you don't know, is a collection of fixes from IBM that they say, yeah, at this date, this is our recommended service level. This is what we expect you to implement. If you're doing that kind of mass change, then scan the system before it goes live. If you upgrade Kix or DB2 or every BMC or every Broadcom product, yeah, we've just gone to the latest version of everything, scan them before they go live. Because if this code, if you did have a problem, gets into production, yeah, all hell can break loose. Because you could seriously, and I cannot believe I found that photograph on the internet. I really cannot, yeah. Why would a law officer, a police, it looks like a policeman, stand there with what looks like some kind of single action shotgun, yeah? Because he seriously could shoot himself in the foot or his buttocks, okay? But if you can scan, you must scan. I know I say there you should, but we do find code defects. We find problems out there. Yeah? There's a lot of people investing a lot of time doing this stuff to make these systems secure. Because if you get a code vulnerability and somebody finds it and they know how to exploit it, they can bypass every single control you have got on your system. Forget about RACF, ACF2 and top secret. I can ignore all of that. Yeah? If I'm an ACF2 site, I can give myself non-cancel. If I'm a top secret site, yeah, all the different controls. If I'm RACF, give myself system special. Yeah? What can't I do if I'm system special from a RACF perspective? I can't change any of the audit settings. So the first thing I do is give myself the auditor attribute, then change all the audit settings, then start turning everything off. Yeah? So all that real-time monitoring and all those controls are all gone. So, RACF, ACF2, top secret, bypass them all. ZOS, Kix, IMS, DB2, all those controls you might have in there, all this fancy code you've written, bypass the lot. Monitoring, SMF, real-time, turn it all off. Because you actually have complete control. All those processes, privilege access monitoring, I've just turned it all off. Gone. Just about everything. And when I say total control, okay, I mean total control. Once you are in key zero supervisor state, I've moved from problem state to supervisor state, I can issue any instruction on the mainframe I want. We had a little bit of a play once with a client on their DR system, and we said, we found this piece of code, we think it's exploitable, this is how we do it. He said, well, you couldn't turn the mainframe off. Has anybody ever come across the ZOS MVS command called quiesce? So it's a little bit like, I've just put my laptop into sleep mode. So we actually just wrote a tiny little piece of code, SVC34, which is how you issue a command from assembler, SVC34 quiesce. Everybody was, God, how on earth have you done that? So you kind of hard stop the mainframe. You literally stop the PSW. The most interesting thing was watching the systems programmers trying to work out on the HMC how to do a PSW restart, because that's how you get it, how you get you get the system back up and running. So it's kind of pause, press play again. Now, I worked at a site way back in the 80s where we worked until 10 o'clock of an evening. So as we walked out the door, we typed in quiesce. The day shift came in at 6 o'clock in the morning and went to the HMC, right click, did this, PSW restart, everything comes up. But nobody does that anymore. Who pauses the mainframe for 10 hours overnight now just to let things calm down? Yeah, let the chips cool down a little bit. We don't. So if you're a bad actor or you want to cause some damage, this is like 4 lines, 5 lines of assembler code. There's more documentation than there are instructions, and it's literally one MVS command. But you can use BCP and interface to the HMC and turn off processors, turn on processors, take the storage offline, do anything you want, because you are that much in control. And the thing I try to explain to people is the bad actors have plenty of time. If somebody was to get into your system, if they know what they're doing, they're not going to come in and make a lot of noise straight away. They're going to be deathly quiet. They're going to move around. They're going to take the time. They're going to get creative. They're going to work out where your DB2 databases are. They're going to work out where your vSAM dataset is. They found that file that says customer.master.file or everybody.payroll.data. They found all that data. They've indexed it all. And then when they're ready, they'll press the button. And it really is just what the coding skills are and their imagination. That's where they get to with this stuff. So we have to make certain that we retain integrity of all the code on these systems. Without integrity, we've got nothing, okay? And I found this really interesting quote from Terry Pratchett here, Because when I say to people, what do you need to do? I think it's fairly obvious, but, there's a 7-foot skeleton, with a scythe telling you, you kind of know. I'm not a 7-foot skeleton, but I actually went out with somebody on Saturday night who was 6'7" tall and 300 pounds, okay? I thought I could enjoy myself when I went to a bar, okay? 1 beer. Shall we have another one? Okay, so I'm not that physically capable. But, I think it's fairly obvious what we need to be doing, You have to check, and check again, okay? It's a little bit like driving down the freeway or the motorway with the kids in the back of the car. Are we there yet, Dad? No. Are we there yet, Dad? We should be saying to our systems programmers and our teams, have we got any vulnerabilities? Have we got any vulnerabilities? Have we got any vulnerabilities? And we should become such a PITA to these technical folks and the management folks that they go, why are you moaning and complaining about this much? We're doing it because it's a real issue. And if we don't fix it, we will have problems. Be that pain in the backside. But you've also got to think about, how do you monitor this stuff, in real time? And, we're hearing all, the technology that's coming out there that the people are doing. But you've really got to monitor, those privileged users, those access to those really sensitive files on the system, the commands that allow you to change things dynamically. Anybody know what the MVS setprog, APF, add command does? Dynamically add an APF authorized library. Walked into a client, did a pen test, 4 days. Loads of it, couldn't find anything. Nothing. Went through all, brilliant. One of the guys I was with turned around and said, have you tried the setprog command? No, they'll have that locked down. Straight to the development console, TSO session, mvs.setprog.apf, add, dsname, mark.load. Oh, it worked. It was almost like walking up to a mansion, trying every single window on the mansion and forgetting to check the front door. That's what I felt. We wasted 4 days trying to find something on the system. So sometimes the basics slip through. You've got to check all of these things. However you do it, Yeah, whatever tools you've got, but real-time, proactive mainframe monitoring. And there's some great technology out there today to be able to do this. Because if you have a vulnerability and you have no integrity, you do not have any mainframe security at all. None. All that hard work, those 10 security administrators who are absolutely implementing role-based access control, that off-host platform that's your identity and access management solution that's locked down and tied down and tightly integrated to your mainframe. Yeah? All this real-time alerting, forget it. It's all gone. Without integrity, we have nothing. Okay? And it's as simple as that. So I'm going to finish in 4 to 5 minutes early, but we've still got lots to do, yeah? And for me, our job is going back into our teams and explaining to them that this is a problem and we need to do something about it. And you can't just say, I'm going to scan this month, and then you apply millions and millions of PTFs and loads of new updated software and don't go and scan it. You are just waiting for something bad to happen. So integrity is key to everything. Don't be fixated on ACF2 top secret RACF. Don't be fixated on, I've got CyberArk, I'm doing privilege access management. Don't be fixated on, I'm okay, I've got MFA. These are all great tools that we need in our armory, but without integrity, we have absolutely nothing. So, does anybody have any questions? See, it's early today, isn't it? So, see, I think I've actually upset somebody at Share, because yesterday morning I did a session at 7 o'clock and at 8 o'clock. And today I've got 8 o'clock. So I've obviously upset somebody. So, yes, Bern. Okay, so the question for the online team is, yeah, when these scanners run, do they scan the actual load modules or do they scan the source? They actually scan the running system and the load module. So they tend to work in a couple of phases. The first phase of the scan is, let's inventory everything out there. What have I got in APF? Am I authorizing linked list? What LPA list modules I've got? What's AC1? So it builds this big inventory, and then they'll do various things to those codes. They'll look in and look in the object code and look for the sequence of instructions. They'll do what the non-mainframers call fuzzing, and basically, if it's an SVC, they'll throw parameters at it and see if they can break it. And that's why you never do this on a running production system, because if that SVC is running and it reacts badly, it can actually bring the system down. You can get a bends. So never run these things on your production system unless you're doing it in a controlled change environment. So you might turn around and say to the business, on Saturday, we're going to leave everything running, but we don't want you to use the services because we're going to scan. And if you break something, you re-IPL, everything comes back up, it's okay. That's a hard sell to the business. That's a risk. What happens if I have a corruption on my DB2 database or on my IMS database, or there's a transaction in flight? Yeah, I'm a great advocate of, if you need to do production, do it on a DR copy of it where it doesn't matter. Yeah, Bern, yes. Yeah. So if I summarise the question, is can you do a more focused scan? Yes, the technology allows you to do that. It's not normally the way it's done. So you might scan dev, pre-prod, QA, and then you build the res packs for production. It's all built. You then clone those over to DR or replicate them to DR, fire it up there as the final test before it goes live. The problem you've got with any type of just focus testing, you might just miss something. So it's better to be more inclusive and test as much as you can. Yes, you can look at the APARs and the PTFs and say, okay, these are the modules that have been impacted. We can just go and check those. A lot of the time, we don't get the source code. Yeah, you get the object code and or the load module from the vendor for obvious reasons. Yeah. So the tools will scan the module and tell you where in the module the actual issue is, and you've got to understand a little bit about what you're looking at. I mean, it's a complex space, but the tools are out there. I'm a great advocate of building this into your change management process, but not for just one or two PTFs, unless it's an integrity APAR, a red alert from IBM that says get on it. I'd probably want to test the system now. Yes, we've got it. Get it applied. Test it. Yes, we've fixed it. So you can see the before and after. Anybody got any more questions? Right. For those of you who are following the digital security warrior thing, there's your session ID and there's your badge code for it. Okay. Thank you very much for coming out. I know it's early on the last day of share, but at least it's not a Friday morning at the last day of share. Yeah, 4.5 days.